Shall we begin? Shall we begin? Let's begin now.
Okay, let's begin now. Question 1 says the compound of tin. So the compound of tin is called stannates because the Latin name for tin is stannum. Then number 2 question talked about gases that cannot be collected by upward or downward displacement of air. The answer is B, because the molar mass of nitrogen is closer to that of air, 28.89. So you cannot collect this nitrogen by displacement of what? Air. For gases that are heavier than air, they are better collected by downward delivery, which is the same thing as upward displacement of air. Then gases that are lighter than air, like this one, they are confidently collected by upward delivery, which is equivalent to downward displacement of air. So that's it. So the answer is B, because the molar mass of nitrogen is 28 and the molar mass of air itself is about 28.8. You can watch my video in this channel which says how to know gases that are lighter or heavier than air. Then coming to number 3, which says that if the azimuthal quantum number is 2, what is the maximum number of electrons each shell can hold? That is the shell will hold. When we say that azimuthal quantum number L is 2, it means that it is for D subshell. That means when it is S, azimuthal quantum number is 0. When it is P, it is 1. When it is D, it is 2. When it is F, it is 3. So you should know that D subshell can hold maximum of 10 electrons. You can follow this order, which says that L stands for azimuthal quantum number and M is for magnetic quantum number, which ranges from minus L to 0 to plus L. So what we have here, if the azimuthal quantum number is 2, therefore possible subshells or possible suborbital will be minus 2, minus 1, 0, plus 1, and 2. So we have 1, 2, 3, 4, 5. That is why D subshell have 5 orbitals. Therefore, each orbital will go to, the answer is 10. Then coming to number 4, which is telling us about carbonates that do not exist. The answer is aluminium carbonate. The option D, which is malachite green, is copper carbonate, copper hydroxide. So it do exist.
Hi guys! My name is Shermaka Arizi. I am a second year medical science.
My name is Sushma Tripathi and I'm a first year medical student.
We're here today to ask you to please subscribe to Sir Majesty Easy World.
It has cool experiments and it makes science fun. So, subscribe!
Please.
Okay, number 5, the correct answer is option D. Lucas reagent is used to classify alcohol. It will enable you to know primary, secondary, and tertiary alcohols. So, and it's a solution of zinc chloride dissolved in corn KCl. Then coming to number 6, you follow the Graham's law of diffusion, follow it step by step as shown, and you get your final answer as D. It is clearly solved and explained here. Don't use this method because it will not conform with Graham's law of diffusion. Don't go dividing the molar mass straight because the law did not say the mass is direct, rather the square root. The square root, not the mass or the density direct, rather the square root of the density, which is what we did, and is inversely proportional to the rate. So this is what we got. The correct answer is 1:2. Okay. According to Markov-Nikols's rule, in this case, the 2 carbons surrounding the double bond, there is a way they share from the hydrogen and the halogen. This rule is only applied, as you can see here, when hydrogen halides reacts with alkenes and also alkynes, in this situation, the carbon bearing more hydrogen will take the hydrogen. So this carbon have 2 hydrogen, and therefore will take the hydrogen. That's why this hydrogen came here. And this carbon have 1 hydrogen, and therefore will take the chlorine. Not like this. This chlorine will not come here because this one have more of the hydrogen. So rather, the hydrogen will come here. The one with more hydrogen takes the hydrogen, and the one with less hydrogen takes the halogens. So that's it from Markovnikov's rule. It stands like the rich gets richer and the poor gets poorer. Now we get here. On number 8, the answer is A. This is the reason. This should be the reason why there is no change in the mass number, because in beta particle, in decay involving beta particle, there is only conversion of a neutron to proton, which will not change the mass number, but will change the proton number, as you can see here, because mass number is equal to proton plus neutron. So changing one to the other will not affect the mass number, rather will affect the atomic number, as you can see here. Now, when we come to number 9, the answer is A. Simple. The positively charged ion is the metallic ions, which ionize by losing electrons. That is the electron shares. The shares in the outermost shell, the electrons in the outermost shell are free to move around, and that brings about metallic bonding. Then number 10, as you can see here, follow it in order and see what we call equivalent mass. Some compounds have half of their molar mass as their equivalent mass. Some have their molar mass as also their equivalent mass. As you can see here, HCl, 1 gram of hydrogen can only react with 35.5 grams of chlorine, and the equivalent mass of chlorine is still 35.5. Then coming to that of sulfur from the equation, sulfur is 32, but the equivalent mass is 16, because from here it shows that 2 grams react to 32, so 1 gram will react to 16. That's just it. Question number 11 is to check if you know the definition of vapor density. So if you can define vapor density, that was what is defined in that question. Therefore, from that it shows that vapor density is 22, and relative molecular mass is 2 times vapor density. Therefore, 2 times 22 is 44. So the answer is C. Coming here, helium is the smallest size atom. It is smaller than hydrogen. Hydrogen is the simplest atom, but helium is the smallest. Then number 13 is is tempting you to answer colorless. If you react reducing agents versus KMnO4, the color change depends on the medium that the reaction is taking place. If you acidify KMnO4 and bubble reducing agent, it will take it down to colorless or very pale pink manganese 2. But when it is alkaline, it's going to take it down to green. You can also do yourself good by watching the color changing miracle here in this channel, so that you see what we are saying. When we reacted KMnO4 under alkaline medium, it will turn it green and not colorless. Alkenes there, specifically ethene, will turn acidified KMnO4 colorless, but when it is alkaline medium, it will turn it from purple to green. So calculating the EMF of a cell, you get to know the electropotentials. You take the highest positive value. What you do, for example, they give us 0.34 for one of the cell, then minus 0.76 for the other cell. What you do is you hold one constant and change the other, meaning this is plus 0.34 constant. We are holding this also constant. We have minus 0.42 volts. Then holding this constant again. What do you have here? You have now plus, changing this minus to plus. So you get 1.1. So 1.1 is higher than 0.4. So the EMF should be equal to 1.1. And this is your Daniel cell. Daniel cell. Now, assuming they gave us these values, 2 negatives, see how to get it. You hold this one constant, then you vary this. This one is minus, here you get the cumulative. Plus minus is minus, so you have minus 3.47. Then here, this is still minus, then you change this minus to plus. Then it will give us minus 1.95 volts. Then change this minus to plus and keep this one constant. So you have that this is plus 1.95. So if such cell have this, the answer should be plus 1.95 volts. There is no need of saying make this one let's say if you keep this one minus again and change this one to plus, it will still go back to this we have done before. So you take the value that is higher. The highest positive value should be the EMF of a cell. Then coming to number 15 is just 2-chlorobutane 1,2-diene. That is the answer. Then 16 is A because 1,2,3 trihydroxybenzene is pyrogalol, and pyrogalol under alkaline medium is used to absorb what? Oxygen. So passing a mixture of air through this will remove only oxygen. The question is just to check if you know the IUPAC name of pyrogalol. Students commonly know that alkaline pyrogalol is used to absorb oxygen, but the question is, do you know the IUPAC name? And look at the structure. And the structure is 1,2,3 trihydroxybenzene. It's used to absorb oxygen, especially in alkaline medium. Coming down here, number 17 asks us which of them will yield alkanone on oxidation. Primary alkanols yields alkanals on oxidation, that's partial oxidation. Then complete oxidation gives you alkanoic acid, that is for primary alkanols. That is alkanols that have only one alkyl group attached to the carbon bearing the OH. But they are asking us the one that will yield alkanone. The oxidation of secondary alkanols yields alkanone. Here from the option butane 2-or, which is this 1, 2, 3, 4. At carbon number 2 there is OH. Then check around the carbon bearing the OH. There are 2 R. This R here, which is CH3, and another R here, which is C2H5, which means this is a secondary what? Alkanol. So on oxidation is going to yield an alkanone. But ethanol, for example, on oxidation will yield ethanol because it is a primary alkanol. So that of a tertiary on oxidation doesn't yield anything. So when we come to the question number 18, we use this cheat, Ramit over Chaffer. I taught you this on about first law of Faraday's. The facts are given here clearly. We just make charge the subject of the formula. These are the figures they gave to us. So when you substitute, you find out that on making subject of the formula, charge is equal to Ramit over Faraday times mass discharged. RAM, relative atomic mass, IT is current and time. Then the question they gave us the number of protons and neutrons. If that element has 14 protons, if that element has 14 protons and 13 neutrons, or the other way, I think it should be 14 neutrons and 13 protons. It means that the molar mass should be 27, which is equivalent to relative atomic mass. After substituting, we find out that the charge present on the element is +3, and probably that is aluminium.
The trioxonitrates of group 1 metals decomposes on heating to yield nitrites, that is, their dioxonitrate 3 of the metal, and oxygen, except that of lithium, which decomposes to yield lithium oxide, reddish brown gas, NO2, and oxygen, just like the group 2 trioxonitrates. Lithium compounds have characters similar to that of magnesium because of diagonal relationship in the periodic table, just like beryllium and aluminium, boron and silicon, which are all semiconductors. Trioxocarbonates 4 of group 1 are also stable to heat except that of lithium. The trioxonitrates of calcium to copper in the activity series of metals decomposes on heating to yield their respective oxides, oxygen, reddish brown gas, NO2, while that of mercury, silver, and gold yields their metals. So heating silver nitrate strongly will produce silver metal. Here are some examples showing you the decomposition of group 1. 22, the answer is C because they are hydroxides and amphoteric, that is, having both basic and acidic property. Therefore, in the presence of soda hydroxide, they behave like acids and form complex salts, which are all soluble. This is used in salt analysis to detect the presence of these ions. Considering these facts, if the oxidation number is +3 already, it shows that it already has excess of 3 protons. Then, after losing another 3 electrons, it will now have a total of 6 excess protons, which corresponds to +6. Remember, protons are positively charged and hence increase in oxidation number from +3 to +6. Question 27 is A. Dinitrogen 1 oxide. This gas is commonly called laughing gas. Behave in a similar way with oxygen by rekindling glowing splinter, but unlike oxygen gas, laughing gas is an anesthesia used commonly in dental surgery, and it is also having other qualities. Watch my video here, Rekindle Your Flame. Test for oxygen and production of oxygen in the lab to see the differences between dinitrogen 1 oxide and oxygen gas. You're doing great. For sure you must succeed in your JAMB. This guide exposes your weakness and gives you courage to face the JAMB. When you finish this and find the nitty-gritties and the short ways to do things, I assure you for chemistry you will score not less than 90 something in your JAMB. So share this video and let others know about this. Don't succeed alone. Let your success have a partner. Subscribe and see you in the comment box. The oxides of very reactive metals such as sodium, potassium, calcium, magnesium and aluminium are very difficult to reduce to their metals. That is why these metals are extracted by electrolytic reduction and not thermal and chemical reduction. By actions, nucleophiles are Lewis bases while electrophiles are Lewis acids. See you in the comment box. Let's interact there for further information.
I'm a medical student in St. Lucia, and I'm here to encourage you to subscribe to Sir Majesty Easy World. He does fun experiments and science on his channel, so please subscribe, and yeah, we'll have a good time.
Yeah, you will definitely have a good time in your exams. Feel free to demand tutorial on any topic you are finding difficult in science. Sir Majesty Easy World is an online school of science. Science is made easy with practical illustrations. For question 57, watch my video on flash powder and production of gunpowder for clear understanding. For question 68, watch my video on brown ring test for clear understanding. 69, watch the video make nitric acid by dry distillation. These things will be clearer for you, I assure you. According to Bronsted and Lowry acid-base theory, a conjugate base is a species that will gain a proton to form an acid. If you add hydrogen ion, that is a proton, to the cyanide ion, you will have the acid HCN. Therefore, cyanide ion is a conjugate base of the acid HCN. In the other hand, a conjugate acid is a species that will lose a proton to form a base. In the equation, hydroxonium ion, that is H3O+, is a conjugate acid of the base water. The limitations to this theory is that water can act as a base and also act as an acid, while we all know that water is neutral. And this theory also sees acid-base reactions as reversible reactions. Two species that are related by proton loss or gain are called conjugates. Look at the equation, you see that cyanide ion and HCN are conjugates. Be careful with question 67, which is cetane number. Don't confuse cetane number with octane number. Octane number measures the quality of a petrol, while cetane number measures the quality of a diesel for diesel engine. Do you know that science can help you in skill acquisition? That's why we have this package for you called DIY, Do It Yourself, here in this channel. There is a video that teaches practically how to make special body lotions and creams, even hair creams. Teaches the sciences behind the raw materials used, their effects on your skin. So don't miss any part of this. Keep your skin healthy and fresh. Do you know that there are a lot of amazing reactions in science? It will surprise you and beat your imagination. Just like a powder when you touches it, it will explode. Then we have start fire with water, a hydrogen balloon that disappears in the air without coming back, auto-exploding balloon, even watermelon explosion that we showed you here in this video. All and many more are available for you in this channel. Check it out on my playlist under Science Tricks and Hacks, and enjoy, learn with fun.
Majesty.